All right, so we are looking at 6.1. We're talking about inverse circular functions. So if you remember just inverse functions, if we have y equals 2x, this is a function, you could rewrite it f of x equals 2x, right? Same thing? Agreed? So to find the inverse, do you guys remember what you do? We interchange our x and our y, so it would become x equals 2y, and then we solve for y. Meaning I'd have to divide by 2, yes? So if I divide by 2, I get 1/2 x equals y, or y equals 1/2 x. And then your inverse, remember, is f negative 1 of x equals 1/2 x. Everybody remember that? So if we were to graph these, remember this one, you'd start at 0, 0. You'd go up to right 1, down 2, left 1, and it would be a line that kind of looked like this, yes? And for the other one, we'd start at 0, 0, and we'd go up 1, right 2, down 1, left 2, and it would look like this, yes? Remember, inverse functions reflect across this line y equals x. So they should look the same on the left and the right of that line. You should be able to fold them over. So just a quick reminder of inverse functions in general. So now we're talking about the circular functions. So we're talking about sine, cosine, tangent, secant, cosine, cosecant, cotangent, yes? So a function is defined so that each element is used only once. Then it's called a 1-to-1 function, meaning, remember when we were talking about 1-to-1, neither the domain nor the range repeat. You guys remember that from Algebra 2? Okay. So inverse sine is f negative 1 of x, yes? Sorry. All right, the horizontal line test determines, vertical line test determines a function. Horizontal line determines whether it's a 1-to-1 function, right? Because that'll tell us whether the range repeats. Your inverse function is denoted by this f negative 1 of x. So, in a 1-to-1 function, each x value corresponds to only one y value. If a function f is 1-to-1, then it has an inverse. So if it's not 1-to-1, then there is no inverse function. There's an inverse relation, but not an inverse function. The domain of f is the range of the inverse. So your domain of your function is the range of the inverse, and the range of the function is the domain of the inverse. Remember, your x and your y switch. The graphs of the function and the inverse function are reflections across that line y equals x. And to find it, we replace f of x with y, interchange x and y, solve for y, replace it with f negative 1 of x, yes? So thinking about sine or inverse sine. Well, let's talk about sine first. So just sine of x. So remember, sine of x, we had something that looked like, yes. Oh, awesome. That's cute. In sine of x, it looked like this, didn't it? And it went up 1 and down 1, yes? Do we all remember that? So the domain of this was from negative infinity to infinity in general. Now we would have to limit that if for the horizontal line test, yes? So you're going to have to limit it for the horizontal line test. But The big thing is the range. Yes, your range went from -1 to 1, didn't it? So for inverse sine, we know that is our domain. So it goes from -1 to 1. And the point 0, 0 would still be 0, 0. Okay? But here we'd have it down here and up here, and it's going to look like, well, that's not very, sorry, that's not very good. There is a curvature to it. We go from -1 to +1. I should do the trig function. So you can see there, if I limit this to -1 to +1, what it kind of looks like there. There's more of a curve. And I have my curve wrong. Kind of looks like that. So if you remember in one of the, I don't remember which chapter it was, we talked about the ranges of the trig functions. And I said that's going to become more important later on. This is where it's more important now. So looking at this, your ranges here for sine is negative. Your domain was -1 to 1. This was -π/2 to π/2. So your range was in that. Your domain was from -1 to 1. It's going to switch, right? Your interval here, this is what matters, is which quadrants they can be in. So remember we said all students take calculus, yes? None of your inverse functions exist in quadrant 3. So you can automatically cancel that out. So sine has to be positive, inverse sine has to be positive and negative. Well, all of the inverse functions are going to exist in quadrant 1, okay? Sine would be positive again in quadrant 2, right? It is not going to exist in quadrant 2 for the inverse function. So inverse sine is going to be negative in quadrant 4, positive in quadrant 1. Cosine is positive in quadrant 1. If we move to quadrant 4, it wouldn't exist there, right? Because it would be positive there also. And so it exists in quadrant 2. Tangent is in quadrant 1 and quadrant 4. So positive in quadrant 1, negative in quadrant 4. Cotangent is positive in quadrant 1, but negative in quadrant 2. Cosecant is in quadrant 1 and quadrant 4. And secant is in quadrant 1 and quadrant 2. So you're noticing your ranges here for sine is from -π/2, which would be here, to +π/2. You cannot go through quadrant 3 on these. So that means you can't go all the way around. Okay? You'd have to start at -π/2 to +π/2. Cosine is from 0 to pi. Tangent is negative pi over 2 to positive pi over 2. It doesn't exist at pi over 2 and negative pi over 2 because think about asymptotes, yes? Okay. Cotangent is from 0 to pi. Secant is from 0 to pi. Cosecant is from negative pi over 2 to positive pi over 2. All right, let's look at example 1. You have to know this. Like, you're going to have to make sure you know it. Your domains are a big one, which are the ranges of the original functions, right? All right. Looking at example 1. Now here, it says something about arc. What you need to realize is that inverse sine and arc sine mean the same thing. So inverse sine and arc sine mean the same thing. Same thing with inverse cosine and arc cosine. Inverse tangent, arc tangent. Arc just means inverse. It's interchangeable. So in example 1, it says find y in each equation. Well, y equals arc sine of 1/2. This would be your x value, wouldn't it? So if we wanted to figure that out, we could say, okay, well, what are we talking about? We're talking about 1/2 equals sine of y. So we're looking for an angle measure here, yes? When we're looking for an inverse function, we're looking for an angle measure. Well, let's think about our, first of all, inverse sine exists in quadrant 1 and quadrant 4, right? From negative pi over 2 to positive pi over 2. And since it's positive, we're only talking about quadrant 1, yes? So in quadrant 1, do we have a special right triangle where the opposite side is 1 and the hypotenuse is 2? Yeah, 1 square root of 3 and 2, yes? What angle measure would this have to be? 30 degrees, but you're going to always do these in radians, unless it says differently. So if we're talking about y equals 30 degrees, we need it in radians, so I'd have to multiply by pi over 180. So what does y equal? Pi over 6. Questions on that? All right, let's look at B. Remember, if you have something like x equals sine of, well, let's start with y equals inverse sine of any x value, right? If we just wanted the regular function, not the inverse function, we could switch those variables and x would equal sine of y, yes? That's how we switch the variables in order to find the inverse, yes? Okay, so let's first of all, let's think about this. What is the domain of an inverse sine? -1 to 1. Inclusive. Yes? So 1/2 fit in that, yeah? -1 fits in that, yes? So we're talking about where -1 equals sine of some y value, yes? Some angle measure. So remember, you are talking about from negative pi over 2 to positive pi over 2. We can only go through these two quadrants, yes? Where would sine be -1? It's going to have to be on a quadrant, isn't it? On an on an axis, excuse me. It's going to be one of those quadrantal angles. Do you remember that? So here we know we have the point 0, 1. We have the point -1, 0, and nope, I just said that opposite. This would be right 1, up 0. This would be over 0, down 1. This would be over 0, up 1, yes? Sine is which coordinate? Y coordinate. So where is sine equal to -1? At? So y would equal -π/2. So you're trying to find the angle measure when you're trying to find an inverse function. Look at C. Does anybody see a problem with this?
Yes.
Yes. It has to be between -1 and 1, right? So right there, that's not between -1 and 1. Sine of y cannot equal -2. So this does not exist. You're correct. It's not in the domain. Okay. So inverse sine. Your domain is from -1 to 1. Your range is from -π/2 to +π/2. You can see here what this looks like. Yes? The inverse sine function is increasing and continuous on its domain, meaning it's going up from left to right. It's continuous, meaning there's no asymptotes or breaks. The x-intercept is 0, as is the y-intercept. Its graph is symmetric with respect to the origin and is an odd function. So think about symmetric with respect to the origin. That means if I flip it across the x and the y-axis, it's the same. If you flip it across here and here, right? You got to flip both ways. Your x becomes your y becomes your x. All right, inverse cosine function is what we're talking about next. Okay, so your inverse cosine function is between 0 and pi. Y equals cosine -1 of x is the same thing as arc cosine. Let's look at this. Where would arc cosine be 1? Well, first of all, is that between 0 and pi? Yeah, between 0 and approximately 3.14, it is. So then here, when I look at this, I know I'm going from 0 to pi. And where would it be 1? Well, we're talking about where cosine of y equals 1, yes? So again, you're going to have to talk about a quadrantal angle, correct? Because the only way you're going to have one with a special right triangle is with tangent of 45 degrees. Do you agree with that? All right. So here we go right 1 up 0, over 0 up 1, left 1 up 0. So we're talking about right here, we know cosine is the x coordinate, correct? So you're talking about where y equals 0. Does that make sense to you? 0 radians specifically, yes? All right, here, cosine -1 of this. So we're talking about cosine of y equals -√2/2. Now that would have been a rationalized form, wouldn't it? We don't have anything special with square root of 2 and 2, yes? So let's re-rationalize that. So I multiply by square root of 2 over square root of 2. We're talking about where cosine y equals -1 over the square root of 2. Do you agree with that statement? So again, cosine's between 0 and pi. So where is cosine negative, quadrant 1 or quadrant 2? Inverse cosine, I should say. It's got to be in quadrant 2, right? Okay. So then here, when we look at our special right triangle, we're talking about the adjacent and the hypotenuse. Is that a special right triangle? Yeah? 1 square root of 2, what angle measure would this be? 45 degrees or pi over 4, do you agree? Yeah? But I'm really looking for this angle measure, aren't I? Because it goes from 0 to pi, so I'm looking for this. I'm not looking for my reference angle, I'm looking for the angle, yes? how do you find that angle? Either 180 minus 45, or what I would have done was pi minus pi over 4. Because pi minus pi over 4 is 3 pi over 4. To me, that is easier than saying this is going to be 135 degrees and then changing it to radians by multiplying by pi over 180. Does that make sense? Questions so far? All right. So inverse cosine is going to look like this. We remember cosine looked like this, yes? Oh, of course you can't, because I'm too far up. Just kept going? Yeah? So between -1 and 1, it would be this right here, yes? It is between 0 and pi. So 0 and pi would have been what? Right here. Yeah? Your domain was 0 to pi, then your range would have been 0 to pi on this. Make sense? Okay. So you can see here, for cosine, you had the point 0, 1. Yeah? For inverse cosine, we have the point 1, 0. Yes? Here, we would have had the point, what, pi over 2, 0? Yes? Here you have the point 0, pi over 2. Making sense? Your x and your y switch. Okay. It is decreasing, meaning going down from left to right, and continuous. The x-intercept is 1. The y-intercept is pi over 2. It is not symmetric with respect to the x-axis, y-axis, or origin. So it is not symmetric. All right, next one is the tangent function. Remember, tangent, we had an asymptote at negative pi over 2 and an asymptote at positive pi over 2, and it looked like this, didn't it? Kind of like the cubic function. So its range is between negative pi over and pi, negative pi over 2 and positive pi over 2. And its domain is negative infinity to infinity, because this range was negative infinity to infinity, yes? Makes sense? At 0, 0, we're at 0, 0. At pi over 4, we would have been up at 1, yes? So at 1, you'd be up at pi over 4. Does that make sense to you? Okay. It is increasing and continuous on its domain, meaning it's going up from left to right. The x-intercept is 0, the y-intercept is 0. It is symmetric with respect to the origin, and therefore an odd function. And these are horizontal asymptotes now. Example 3 says find the degree measure. So you'll notice when they use theta, they're asking for a degree most of the time. So if you think about this, you're talking about tangent of the angle theta equals 1. Well, again, tangent is between negative pi over 2 and positive pi over 2, right? Those were the asymptotes for the regular tangent. So where it's positive, it's going to have to be in quadrant 1. Remember, tangent is 1. Remember, tangent is opposite over adjacent, yes? 1, 1, and square root of 2 gives us a special right triangle, doesn't it? What angle measure is this?
45.
Yes, 45 degrees. Questions on that? Okay, secant is going to be the reciprocal function for cosine, yes? So remember, cosine and secant are between 0 and pi over 2. Either way, we know this is going to be in quadrant 1, correct? Do you agree? You can, is it between 0 and pi over 2? I might. Yeah, 0 and pi. My bad. I said pi over 2. 0 and pi. And I have it in 0 and pi. Never mind. Okay, so secant is the reciprocal of cosine. So if we think about this as secant theta equals 2, you could also think about it as cosine theta equals 1 over 2, yes? Because this is 2 over 1. Everybody agree with that? Okay, so cosine is 1 over 2. If we think about that in quadrant 1, cosine is adjacent hypotenuse. Is this a special right triangle? 1 square root of 3 and 2, yes? What angle measure would this have to have been? 60 degrees. I agree. Questions on that? Okay. Example 4 says, find y in radians if y equals cosecant negative 1 of negative 3. So we're talking about here cosecant y equals negative 3, yes? Do you agree with that? Or what about sine? Sine y would equal negative 1 over 3. That's between negative 1 and 1, so we're good on that, right? We know that this would have to be in either quadrant 1 or quadrant 4. Yes? It's got to be in quadrant 4 though, doesn't it? Because it's negative. And so here, sine is opposite hypotenuse. Do we have a special angle, special right triangle? We do not. So we can't find an exact value. We're going to have to find an approximate value. And it's wanting it in radians. So on our calculator, how could we do this? Well, we're trying to find an angle measure. So inverse sine of negative 1/3. Inverse sine of negative 1/3. Making sure my calculator's in radians, right? Because it asks for radians. And this gives me approximately negative 0.3398369, and it just keeps going. 5369095, and that would equal y. So you always want to try and find exact, but sometimes we don't have a special right triangle, so we can't, right? All right, let's go ahead and do this one. It says to find it in degrees. Well, cotangent theta equals negative 0.3541. Now, do you remember where inverse cotangent existed? Think back at your asymptotes for cotangent. Where were your asymptotes for cotangent? 0 and pi, right? So if your asymptotes for cotangent were 0 and pi, it's got to be between 0 and pi, so quadrant 1 and 2. Remember your asymptotes for tangent were at negative pi over 2 and positive pi over 2, right? So it's in quadrant 1 and 4. Does that make sense? So going back to your chapter 4, when we talked about the graphing functions, that's going to help you. So here, cotangents being negative, that's got to be in quadrant 4, yes? So when I do this, it's going to give me the reference angle. We're going to have to take that into consideration. So here, for cotangent, that's what it would be. For tangent, which is what we're going to have to put into our calculator, it'd be negative 1 over 0.3541. 0.41. Now I'm wanting this in degrees, so I'm going to change my mode to degrees. And I would do inverse tangent of -1 divided by 0.3541. It gives me -70.5009, and it just keeps going. But again, that's giving me this reference angle here. So in order to get this angle, what would I have to do? $180, right? So since it's already negative, could I just add 180 to that? If it wasn't already negative, I need to subtract it, right? But here, since it's already negative in my calculator, I can add 180, and this would give me 109.4990544. So theta would equal, here I have 4 significant digits, so I would say that's 109.5 degrees. On this one, it didn't really give me very good significant digits, so I just left the whole thing. Most of the time, it's going to tell you where to round. Questions? Okay, that's where we're going to stop today because that's all your homework is on. We will finish the rest of this on Monday, and that's what the rest of the homework will be on, okay? So you have time right now to work on 1 through 17 odd. You should be able to get a lot of it done, okay?